applications of machine learning in healthcare. And today we will see more areas where machine learning algorithms are used. So such application area is banking and finance. In banking and finance, here the machine learning algorithms are used to detect fraud, automate trading activities, and provide financial advisory services to investors. So prime these are the prime applications of machine learning algorithms in banking and finance. So apart from these applications, we can have other applications like financial monitoring, then secure transaction risk management, algorithmic trading, and many other applications in banking and finance. Now, if we consider manufacturing industry, then manufacturing industry are basically divided into four areas where machine learning applications are heavily used. One is the monitor and predict failure, improve production, that means the productivity, and augment production design, automate operations. So in these four major areas of manufacturing industry, machine learning algorithms are heavily used. Now, if we consider the machine learning applications in transportation, then transportation include car navigation systems, traffic signal control systems, container management systems, and many other applications where the machine learning algorithms are used. Now, if we consider the predictive analytics, so in predictive analytics, here we use the statistical modeling to predict the different outcomes related to predictive analytics. So predictive analytics, we use the statistical modeling in consumer behavior, in pattern discovery, scoring, then determining the scores of different classification and regression models. Then we use predictive analytics in visualization. Then we use predictive analytics in decision making, communication. So these are the different areas where we can use the predictive analytics to get the outcome in terms of classification, in terms of regression, in terms of clustering, and in terms of anomaly detection. And if we see the machine learning tools, then we can see there are numerous machine learning tools. Using these tools, we can design a machine learning application. Okay, so some of the tools may include Python, MySQL, TensorFlow, and then we can have the Kafka. So these are the various machine learning tools. Using these tools, we can design and develop machine learning applications. Okay, so now we will be talking about the different types of machine learning approaches. So roughly we can divide the machine learning approaches into 5 different categories. Okay, so the types of machine learning include association learning, supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning. So these are the rough rough classification of machine learning approaches. So here the association in association learning, basically this association learning is a rule-based machine learning approach where we try to find the hidden relationship between variables or features in a given data set. Okay, so here we try to find the hidden relationships between variables or features in a data set. So if we consider an example, like if we are interested to have a tea in a restaurant, then we may be interested to have some other item like a biscuit or some other food item. Okay, or if we like to have some biscuits, then we are interested to have some other food item like tea, coffee, or other beverages. Okay, so here we can find the probability. Here we can find the probability in association based learning, where the relationship between two or more variables can be relationship between two or more variables can be considered in the given data set. Okay, now next learning approach is known as supervised learning. In supervised learning, we here we try to establish the cause and effect relationship between the variables or features in the given data set. Okay, now here we consider the label data. So label data means the label data is having input and output parameters. Okay, and here we try to establish the cause and effect relationship between different variables or features in the given data set. Okay, so whenever we design a supervised learning technique or supervised learning system, then in supervised learning system, we try to associate the input data, we try to associate the output data with input data. That means there will be the feature vector and range. So both will be associated, and this association will be feeding into the supervised learning system, and we train the system. Okay, so this supervised learning system basically trained on the label data. So label data means here we say label data may be the range, and range may include the different class information or some other identity related information that are being associated with the feature vector. Okay, or the given data. And in unsupervised learning, then the next learning approach is unsupervised learning. So here we don't have the label data, but we can only have the input feature vector, or we can have the relevant data set over which the unsupervised learning system works. Okay, now the task of this unsupervised learning algorithm is to discover the pattern of the data. Okay, discover the hidden pattern of the data. So for example, we can facilitate the grouping of similar items to form clusters, or we can reduce the dimension of the data set. Okay, so the second task is called the dimension reduction. Okay, so if we are having a data set, then either we can go for discovering the hidden structure or the hidden pattern of the data. This is called the clustering, and we can reduce the data to a small number of feature set. So this is called the dimension reduction. Okay, so these two tasks we can perform in unsupervised learning systems or unsupervised learning algorithm. The next machine learning approach is semi-supervised learning. So in semi-supervised learning, we combines small amount of labeled data with a large amount of unlabeled data during training. So here when we perform the training of semi-supervised learning system or semi-supervised learning algorithm, so here we combine small amount of labeled data. That means in labeled data we are having both input and output parameters. Okay, and large amount of unlabeled data. So in the unlabeled data, we are having only the input parameter, but we are not having the output parameter. That means the range is not included in the unlabeled data, but range is included with feature vector in labeled data. And this combination is used for training the semi-supervised learning algorithm or semi-supervised learning system. So for example, we can have generated adversarial network, which is also known as GAN. So generative adversarial network is an perfect example of semi-supervised learning technique where we use both labeled data and unlabeled data. Lastly, we can have the reinforcement learning. So in reinforcement learning, reinforcement learning is basically award based or feedback based learning strategy or learning approach, where we use the feedback to feed to the system, and then the system will adaptively improve itself. Okay, that means, for example, we can take two classes, class A and B. Okay, now if we feed the feature uh, the feature vector with range into the system in a reinforcement learning system, then we expect that the output should be A. Okay, since we are feeding the data related to class A into the system, and we expect the system will give the output related to class level A. But when it outputs the class level or the information related to class level B, then that means we get the negative result, and this negative feedback will then feed to the system to update the information about the corresponding class level. Okay, so in that way we can make correction in the system, and accordingly system will react. So reinforcement learning is nothing but the award based or feedback based learning strategy or learning approach. Now if we consider the practical uses of these machine learning approaches, then we can take several examples. For example, for association learning, we can have many examples, but here we will take a simple example and try to understand how association learning rule is working to establish the hidden relation between different variables or different features. Okay, now here we have two items x and y. Okay, and here we try to find the probability p of item y when item x given. Okay, so here we try to find the probability y given x. So this probability refers that if we are interested to have x, then we may also be interested to have y. Okay, so this is the inference about this probability p of y given x. Okay, now x and y may be any items. So it may be food items, it may be some other items, it may be some other product or services. Now, for example, if x denotes snacks and y denotes coffee, then if we have snacks, then there is a possibility to have coffee with snacks. And for this association, we can have the probability p of coffee given snacks equal to 0.7. That means there is a high chance to have coffee with snacks. So this is the kind of example for association learning strategy or association learning approach. So we can have many more examples. So I'm not going into that details, but later on we will be discussing more on association learning based approach, where we will see we will take a case study and we will solve many such problems. Okay. Now we will take an example of supervised learning approach. So supervised learning approach can be divided into two strategy. One is the classification, another is regression. Now, if we take an example of classification, then the best example for this classification is credit scoring. Now, most of you heard about the CIBIL score. So CIBIL score is kind of credit scoring where we try to classify the two classes known as low risk customers and high risk customers based on two different parameters. So the first parameter is the income and second parameter is savings. So based on these two parameters values, we can design a discriminant function. That means the classification function, and that will classify the low risk customers and high risk customers. Now here you can see a graph where income in x-axis represent the income and y-axis represent savings. Okay, now there are two thresholds for income and savings, theta 1 and theta 2. Now here you can see the red mark red mark red mark bubbles or red mark circles. Here you can see. So these circles, the red mark circles, are making one group, which is denoted by high risk customer, which is denoted as high risk customers, and purple color bubbles or circles make another group of low risk customers. So here you can clearly see that when someone is having is high income but low savings, so they will not be included in low risk customers. Okay, so these will be included in the high risk customer class. Similarly, those who are having low income but high savings, so they also not be included in the low risk customer class, but they will be included in the high risk customer class. So here we can design the discriminant function as if income greater than theta 1 and savings greater than theta 1. That means here we are applying the AND rule between these two threshold. Okay, this conditional threshold. So income greater than theta 1 and savings greater than theta 2. Then we can have the low risk customers. Otherwise, if both these condition or if one of the conditions does not satisfy, then we can have high risk customers. Okay, one of the conditions or both the conditions do not satisfy, then we can have high risk customers class. Otherwise, we can have low risk customer class. Okay. Now, few other classification examples may be pattern recognition. In pattern recognition, we can have different patterns or different objects where we have to recognize the patterns. So if we are having an image and if there are a number of patterns or number of objects which are given in the image, then we have to recognize those objects or recognize those patterns in the image. Okay, so for that we can design a classification algorithm using supervised learning strategy where the data and the range both will be included. That means here we will be using the label data. Okay, so pattern recognition, we can recognize the pattern. In face recognition, we can recognize the faces, and with that face recognition we can identify the person, we can verify the person, we can also match the persons. Okay, now in face recognition, the pose, lighting conditions, occlusions, makeup, hairstyles, so these are the different constraints that we have to consider during face recognition. Okay, so when we design a classification algorithm, supervised classification algorithm for face recognition, so we have to consider this constraint. Okay, or we have to consider these challenges, and considering these challenges, we can design some adaptive supervised learning classification algorithm for face recognition. Okay, the next example is character recognition. Here we recognize the characters which are generally found in different images or different videos, where we recognize the characters by designing supervised learning classification algorithm. Then the next example is speech recognition. So speech recognition is dependent on temporal data, where we have to estimate the temporal dependency. Okay, and we design a supervised learning classification algorithm where we can which can be used for speech recognition. For medical diagnosis, medical diagnosis, here we find here we here we classify the different diseases or different illness based on the symptoms. Okay, and in biometrics, apart from face recognition, we can also design supervised learning classification algorithms for iris, signature, okay, fingerprint. So these are the different biometrics evidences based on which we can design a supervised learning classification algorithm for person identification and verification. Now we will consider an example for regression. So regression is also supervised learning part of supervised learning approach, where we find the relationship between dependent variable and one or more independent variable. Now, if you so here the regression analysis is nothing but a set of statistical method. Okay, and this statistical method are used to estimate the relationship between dependent variable and one or more independent variable. Now if you remember the straight line equation y equals to mx plus c, then using this straight line, so we can use this we use the notion of the straight line to have our regression model. Okay, now statistically, if we represent the notion of straight line as regression model, then the we can predict the continuous value as a response. Okay, so if you remember the equation y equals to mx plus c, then here y is dependent variable and here x is the independent variable. Okay, so and here m and c are slope and intercept. Okay, slope and intercept. So whenever we are having a data set, so from that data set means let us consider a data set of CGPA, average CGPA of a particular year. Okay, and we have the year and CGPA. Okay, so average CGPA. Now, if we are having such data set for 20 years or more than 20 years, then we can predict the CGPA, average CGPA in the coming years using the given data set. So on the given data set, what we will do, if we use the simple straight line equation for that, then we have to basically we have to find the relationship between y and x using m and c. Okay, so in that case, from the given data, we will estimate the slope and intercept. Okay, and then we will find the y. So y means the dependent variable. So x is given. If x is given, then we have to find, and that means if x is found to be here, okay, and then we have to find the y. Y means the CGPA we have to find. And the previous years, in the last 20 years or 50 years, we are having year and the average CGPA. Now year is given, but we don't know what will be the estimated CGPA in the coming years. So that we have to estimate, and that estimation will be done on the given data. Okay, so we can use the straight line equation if we consider the regression model to have with straight line equation, then simply we will find the so M and C. Okay, and X is known. We have estimated M and C from the given data set, and we have to find out what is Y. Okay, so here Y is the dependent variable. So we have to find the dependent value of the dependent variable using one or more independent variables. So similar problem here we are discussing about global warming. So here we consider the data set of average temperature which has been average temperature which has been determined over the last 50 years, okay, or more than 50 years. It may be since we are now doing 2023, so now almost 73 years. Okay, now you can consider that we are having the global average global temperatures over the last 73 years or 72 years. Okay, now we are going to estimate the average global temperature for 2023. So how you will estimate that, or how you will predict that? So these type of problems are nothing but the regression problem. Okay, so in regression problem, we have to we have to predict the response. So whenever we try to predict the response, so it should be continuum value. Continuum means the continuous value. Okay, so continuous value. This continuous value is not found or is not determined in case of classification problem, but in case of regression problem, we have to determine the continuous value. And whenever since we are considering the global warming problem, so in global warming problem we are interested to have the average global temperature in future years. Okay, since we are having the average global temperature for the last 72 years. Okay, now using that data set we can estimate the average global temperature in the coming years. For example, we can predict the average global temperature for 2023. Okay, now for that we can use different regression techniques. One such technique is linear regression, and for linear regression we can use the straight line equation. So when we will be discussing about different regression models, so we will see how we can predict the average global temperature for the coming years using the given data set of the first 72 years. Okay. Now we will consider the practical uses or some examples of unsupervised learning techniques. Okay. Now let us consider there are a machine learning system that we have developed, which is unsupervised machine learning system. Okay, so what we know about unsupervised machine learning system or machine learning approach, that unsupervised machine learning approach works in two different areas. One is clustering, another is dimensionality reduction. Okay, dimensionality reduction. Now for clustering, what we know that in clustering we try to discover the hidden pattern or hidden what we say the hidden data or hidden features in clustering. Okay, so whenever we try to find the hidden pattern using clustering, then obviously we will consider a set of examples or a set of data set. Okay, now here we are having a data set of cats and dog. Different breeds of cats and different breeds of dogs are used to feed into the unsupervised machine learning system. Now how this will work? Now since there are only two groups, so here the data set is unlabeled. So data set is not level. Okay, so data is not labeled. So therefore, whenever we feed this data set into the system will make two different groups. Okay, group 1 and group 2. So and group 1 will be having the different breeds of cats, and group 2 will be having different breeds of dog. Okay, so in this way the cluster will be making. Okay, a cluster will be creating. So if we are having more than other if we are having other animals apart from cats and dog, then we can have more than two clusters. That means more than two groups. So these groups is being constructed, or these groups is being created according to the similarity between the different samples. So since we are considering different breeds of dogs and different breeds of cats, so different breeds of cats will be having the similar properties. Okay, similar characteristics. Similarly, the different breeds of dog will be having similar characteristics, and according to their characteristics these groupings will be done. Okay, now as I said that if there are more than one if there are more than two animals, okay, then there will be more than two groups, there will be more than two clusters. So in this way, since we are here, we are providing the unlabeled data into the system. So therefore, according to the characteristics of the samples, the groupings will be created or groupings will be done. Now, if you see the practical use of reinforcement learning, then here we can take an example of Google DeepMind. Okay, so what is Google DeepMind? So DeepMind is nothing but an AI tool, so which is based on the deep learning models. Okay, now where we use this, we there is a Google data center where the Google data center is housing a large number of high capacity servers. Okay, servers, workstations. Now to reduce the energy consumption of the Google data center, so Google developed a DeepMind AI tool. Okay, DeepMind AI tool. Now, how this DeepMind AI tool facilitate to reduce the energy consumption by 40%. So this is the substantial reduction. So whenever we reduce the energy consumption, so basically we will save the cost. Okay, save our money. So with that thought, the Google developed this DeepMind to reduce their cost by reducing the energy consumption by 40%. So how this is done? Now how DeepMind works, if we want to if we look into the working principle of DeepMind, then there will be a number of steps. So what are those steps? So in the first step, there are a number of sensors, number of cameras are installed inside the Google data center, and they take the snapshot of data from the data centers every 5 minutes and feeding this data to the deep neural networks. That means the DeepMind AI tool. Okay, then it predicts how different combinations will affect the future energy consumption. Now this DeepMind AI tool predict the different combinations. Okay, now we will now the DeepMind AI tool select one optimal combination, so that will reduce substantial amount of energy, and due to that the cost will reduced. Okay, so cost of maintaining the Google data center is substantially reduced, and identifying these actions which will lead to minimal power consumption while maintaining a set standard of safety criteria. Okay, and sending and implement these actions at the data center. So these are the rough steps which are employed in Google data center. So this is the best example of reinforcement learning, where DeepMind uses the feedback-based or award-based learning strategy to reduce the energy consumption. What are the other applications of reinforcement learning? Other applications may include industry automation, trading and finance, natural language processing, healthcare, engineering, news recommendation, and many other applications, robotics manipulation. So we can use the reinforcement learning strategy or reinforcement learning approach. So in these areas. If you have any questions, you can ask me.
So will you share the slides with us?
Yeah, I will share, but let me complete at least one more class. Okay.
Yeah, sure.
So next class will be held on coming Monday at the scheduled time, 1 o'clock in the afternoon. Okay.
Okay, sir.
Okay. After that, I will share 3 slides. These 3 slides or 3 classes. Okay. Okay. That's all for today.
Thank you, sir.